Generally, the responsibility for upgrading service equipment to meet the increased available fault current falls on the owner of the property where the service is installed. The utility is responsible for providing accurate fault current information to customers. The utility may recommend or require upgrades to service equipment if the available fault current exceeds the equipment's capacity. The owner is responsible for the safety and maintenance of the electrical system on their property. If the owner installs service equipment based on the utility's information, they are responsible for ensuring that the equipment remains adequate as the fault current changes. If the service equipment does not meet the NEC requirements, for example, if it is below the required interrupting capacity, there are several potential consequences. The equipment may fail to clear a fault, leading to an electrical hazard or fire. The utility may disconnect service to protect its downstream equipment. The owner may be held liable for any damages or injuries caused by the failure of the service equipment. To address this situation, the following recommendations are advised. Firstly, consult with the utility. Inform the utility about the increased available fault current and request their guidance. Secondly, obtain a licensed electrician. Hire a licensed electrician to inspect the service equipment and determine if it meets the new fault current requirements. Thirdly, upgrade if necessary. If the equipment does not meet the requirements, the owner should upgrade it to ensure the safety and reliability of the electrical system. Fourthly, implement regular maintenance. Inspect and maintain the service equipment regularly to ensure its proper operation. By following these recommendations, property owners can mitigate the risks associated with increased fault current and maintain a safe electrical system. Fault current is the amount of electrical current that flows in a short-circuit condition. Available fault current is the maximum amount of fault current that a utility can deliver to a service location. Equipment must be rated to safely interrupt this level of current. Interrupting rating is the maximum fault current that a device, such as a circuit breaker, can safely interrupt without being damaged. If the available fault current exceeds the interrupting rating of the equipment may fail catastrophically during a fault, causing a fire, explosion, or electrical shock. Electrical codes such as the NEC specify the minimum interrupting rating requirements for service equipment based on the available fault current. The NEC requires that service equipment be rated to interrupt the available fault current at the service. The available fault current can change over time due to changes in the utility system, such as the addition of new generators or transmission lines or upgrades to existing equipment like transformers. Utilities typically provide fault current information to customers upon request. This information is essential for selecting appropriately rated service equipment. In some cases, the utility may require customers to upgrade their service equipment if the available fault current increases significantly. The cost of upgrading service equipment to meet increased fault current requirements can be substantial. The cost will depend on the size and complexity of the service, as well as the type of equipment that needs to be replaced. In general, the owner of the property is responsible for paying for these upgrades. There are several steps that property owners can take to mitigate the risks associated with increased fault current. Firstly, they should obtain accurate fault current information from the utility. Secondly, they should hire a qualified electrician to inspect their service equipment and determine if it is adequately rated for the available fault current. Thirdly, they should upgrade their service equipment if necessary to meet the NEC requirements. Fourthly, they should implement a regular maintenance program to ensure that their service equipment is in good working order. Insurance companies may also have requirements related to fault current protection. Property owners should check with their insurance company to ensure that they are in compliance with all applicable requirements. It's also important to consider coordination of overcurrent protective devices. Coordination ensures that the overcurrent protective device closest to the fault opens first, minimizing the extent of the outage. An electrical engineer can perform a fault current study to determine the available fault current at various points in the electrical system and to coordinate the overcurrent protective devices. The fault current study will take into account the impedance of the utility transformer, conductors, and other electrical equipment. Impedance is the opposition to the flow of alternating current. Higher impedance limits fault current. Lower impedance increases fault current. Utilities use transformers to step down the voltage from high voltage transmission lines to low voltage distribution lines. Transformer impedance affects the available fault current. Lower impedance transformers allow more fault current to flow. The size of the transformer also affects the available fault current. Larger transformers can deliver more fault current. When a utility upgrades a transformer to a larger size or a lower impedance, the available fault current at the service will increase. In addition to the service equipment, other electrical equipment in the building may also need to be upgraded to meet the increased fault current requirements. This equipment may include panel boards, switchboards, motor control centers, and individual circuit breakers. It's important to consider the interrupting rating of all electrical equipment in the system when assessing the impact of increased fault current. Some older electrical equipment may not have an interrupting rating that is high enough to meet the current NEC requirements. This equipment will need to be replaced. Arc flash is a dangerous electrical hazard that can occur during a fault. Arc flash can cause serious burns, blindness, and even death. The severity of an arc flash is determined by the available fault current and the clearing time of the overcurrent protective device. Higher fault currents and longer clearing times result in more severe arc flashes. It's important to take arc flash hazards into account when selecting and installing electrical equipment. Arc flash studies can be performed to determine the potential arc flash hazards at various points in the electrical system. The results of an arc flash study can be used to select appropriate personal protective equipment, or PPE, and to implement safe work practices. PPE includes items such as arc-rated clothing, gloves, and face shields. Safe work practices include energizing equipment before working on it and using insulated tools. Some utilities offer programs to help customers upgrade their service equipment to meet increased fault current requirements. These programs may include financial assistance, technical assistance, or both. Property owners should contact their utility to learn more about these programs. It is important to maintain detailed records of all electrical equipment, including the manufacturer, model number, serial number, and interrupting rating. These records will be helpful when assessing the impact of increased fault current and when selecting replacement equipment. It's also important to keep records of all electrical inspections and maintenance. These records will help to demonstrate that the electrical system is being properly maintained. The NEC is updated every 3 years. It's important to stay up to date in the latest NEC requirements to ensure that the electrical system is in compliance. State and local electrical codes may also have requirements related to fault current protection. Property owners should check with their local authorities to ensure that they are in compliance with all applicable codes. Electrical safety is the shared responsibility. Utilities, property owners, and electricians all have a role to play in ensuring that electrical systems are safe and reliable. By working together, we can reduce the risk of electrical hazards and protect lives and property. In summary, when a utility increases the available fault current, the property owner is generally responsible for upgrading the service equipment to meet the new requirements. It is important to consult with the utility and a licensed electrician to assess the situation and determine the necessary upgrades. Failing to upgrade can have serious consequences, including equipment failure, service interruption, liability, and safety hazards. Regular maintenance and inspections are essential to ensure the proper operation of the electrical system. Property owners should also be aware of arc flash hazards and take appropriate precautions. By taking these steps, property owners can mitigate the risks associated with increased fault current and maintain a safe and reliable electrical system. The National Electrical Code Section 110.9 addresses interrupting rating. Equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Equipment shall be readily available to determine its interrupting rating. Equipment intended to interrupt current at other than fault level shall have an interrupting rating at nominal circuit voltage sufficient for the current that must be interrupted. Section 110.24 covers available fault current. Service equipment shall be legibly marked in the field with the available fault current at the service. The field markings shall include the date the fault current calculation was performed and be of sufficient durability to withstand the environment involved. If modifications or additions are made to the electrical system that affect the available fault current at the service, the available fault current shall be recalculated to ensure that the service equipment ratings are sufficient for the increased fault current. The recalculated available fault current must be field marked on the service equipment with the date of the recalculation.